This video is on Unit 2 on quadratic functions, Chapter 4, complex numbers, lesson number 1, simplifying radicals review. So in this first lesson, what we're going to talk about is how to simplify a radical. This is something that you would have learned in probably geometry. In the notes here under algebra review, radicals, the first bullet says that a radical is any expression with a square root, cube root, etc. The radical symbol is what a lot of you refer to as a square root. You call it a square root. Please understand that sometimes that symbol can have a little number that is going to indicate not a square root, but in this case, a cube root. I can make that a 4, and then it becomes the fourth root, and so on. So that symbol I will typically refer to as not a square root symbol, but a radical symbol. It's just all about vocabulary, knowing your vocabulary. The third bullet says to list the first 20 perfect squares, and I've already done that. Perfect squares are numbers that are created by a number times itself. So 1 times 1 is 1. 2 times 2 is 4. So 4 is a perfect square because it's 2 times 2. 49 is a perfect square because it's 7 times 7. 144 is a perfect square because it's 12 times 12, and so on. So you get the idea there. Knowing your perfect squares does come in handy if you want to simplify radicals by hand. So case number 1 says perfect squares. When you go to simplify radicals, what you want to do first is identify whether or not you have a perfect square. And then just take the square root of that number and you're done. In the second case, for non-perfect squares, you're going to break the radical down using the largest perfect square, take the square root of the perfect square, and leave the leftovers under the radical. So anything that you can't take the square root of has to stay under the radical. For both cases, if there is a coefficient outside the radical, you're going to multiply this with any number that you bring out or that you take out of the radical. So let's look at some of these first examples. The directions here say to write each expression below in simplest radical form. Number 1 and number 2 are both perfect squares. 49 is 7 times 7, so the square root of 49 is 7. 225 is 15 times 15, so the square root of 225 is 15. On the third one, the number that's under the radical, the 144, is a perfect square, but you have a number in front of the radical. So what happens here is when we take the square root of 144, which is 12, you have to multiply that 12 times the 2 to get the final answer here, which is 24. Number 4 and 5 and 6 are all perfect squares. 4, 5, and 6 are all perfect squares. On example number 4, the square root of 4/9, all you have to do is take the square root of the top and square root of the bottom. 4 is a perfect square, 9 is a perfect square. The square root of 4 is 2, the square root of 9 is 3. Done. The same thing is going to happen on 5 and 6. The square root of 1 over 81, what's the square root of 1? 1. What's the square root of 81? 9. So the square root of 1 over 81 is 1/9. And the same thing on number 6. The square root of 36 is 6. The square root of 121 is 11. So the square root of that fraction is 6/11. Now let's talk about number 7. We've got the square root of 112. So to use the method that's listed up here in the notes, case number 2 for non-perfect squares, because 112 is not a perfect square. If you look at your list of the first 20 perfect squares, 112 is not there. So what we're trying to do is to pick the largest perfect square that is a factor of 112. So 112 is going to fall between 100 and 121. So I know that the largest perfect square is going to be 1 to 100. So some number in there is a factor of 112. And if you're not good at this, you're going to grab your calculator. You're still going to grab your calculator, and you're going to start dividing. 112 divided by, let's say, 9 squared is 81. No. 112 divided by 8 squared is 64. That's a no. 112 divided by 49. No. 112 divided by, so obviously I picked way too close to 100. Let me jump down to 4 squared is 16. And there, finally, I get it. And again, y'all, and I shouldn't have skipped it. If I did divide by 36, it's not going to work. 112 divided by 25 is not going to work. So when I finally get to the 16 and I get a nice number like 7, a whole number, again, you're looking for that whole number. Think about your number systems. When you divide by a perfect square, you need a whole number. You don't need decimals here. So what I'm going to do is I'm going to rewrite this as 16 times 7, because 16 went into 112 times 7. And then from there, what is the square root of 16? The square root of 16 is 4. And the 7 is what we call the leftover part. It has to stay under the radical. So the square root of 112 simplifies to 4 radical 7, or 4 square root of 7. Let's do another one like that. 245, the square root of 245. So if you're looking at your perfect squares, 245 falls between the 225 and the 256. So I need to start dividing by the numbers that are close to that. Not too close, because obviously they're close to the number that we're looking at, which again is 245. I'm going to start, well, let's just start 245. Let's just start. Divided by, let's say 144. Obviously, this is not going to work. 245 divided by 121 is the next one. 245 divided by 100, not going to work. 245 divided by 81 is next. 245 divided by 64, nope. 245 divided by 49, yes, finally. So 245 breaks down into 49 times 5. So the square root of 49 times 5. The square root of 49 is 7, and the 5 is left over, so it stays underneath. And the next one that I want to look at, again, just doing it by hand, is number 9. We've got 5 times the square root of 72. So the 5, leave the 5 alone for just a second. The square root of 72, we've got to figure out what that's going to break down into. So if I take 72 and I start dividing, I'm going to divide by, let's divide by 36. Aha, 36 times 2. Here's another little hint. When you divide and the number that's left is prime, you've got the largest perfect square. So 36 and 2. So 36 times 2 is equal to 72. The square root of 36 is 6. And the 2 is left over. And then 5 times 6 is 30 times the square root of 2. All right. So on these last 3 in the notes, I want to show you a little calculator trick. And I'm going to be honest. You end up having to use, when you have a larger number like number 8, when you have a larger number like 245, you end up using the calculator anyway to divide 245 by all of those perfect squares. Well, I've got a shortcut. I'm going to start with number 11. I'm trying to simplify the square root of 250. Now, another little tidbit of information. On a square root, the understood index is 2. Let me say that again. On a square root, the understood little number on that radical symbol is an understood 2. That's important. So what I'm going to do is I'm going to go to the y equals screen. Clear out anything that you have in your calculator. We're going to take that 250 and we're going to divide by x squared. And again, we're using the square because we've got a square root. So that number is going to match the index of your radical symbol. If we were looking for a cube root, we would divide by x to the third. So here's the thing. By using this feature in the graphing calculator, the graphing calculator is doing all of the things that I just did by hand. So over here on this screen, I kept dividing by the perfect square. I took the 245, I divided by 64. 245 divided by 49. What the calculator is doing for me is all of that work. So to find our final answer, we're just going to hit second graph. What that does is it brings up the table of ordered pairs. And we need to focus on just the positive x's. Do not go into the negative. We're focusing on the positive x's. And here's what you're going to do. Look at the y column. I want you to focus your efforts, focus your eyes on the y column. What you're going to do is you're going to arrow down until you see those y's turn over to a number that's just less than 1. So all the way down here, I'm seeing a number to the left of the decimal. And finally, when I get to 16, there's a 0.9766. That means my answer is up above. The first whole number that we come to is going to be our answer. So let me arrow up. 2.5 is not a whole number. Keep going up, up. Okay, so the 10. 5 and the 10 are two pieces of your answer. The x is always the number on the outside of the radical. The y is always the leftover. So this becomes 5 times the square root of 10. That's my answer. Just to kind of give you another example, let me jump back to number 8. I've already done 8 by hand. But let me show you how quickly this answer appears by doing it in the y equal. So I'm going to go back to the calculator. I'm going to go back to y equal, and I'm going to do 245, again divided by x squared because we're looking at square root. Second graph brings up the table. Arrow down. It pops over. It drops below 1 here. The first number I come to in the y column, that's a whole number, is 5. 7 times the square root of 5 is our answer, and that's exactly what we came up with when we did it by hand. Let's look at number 10. Number 10 says 9 times the square root of 45. Now, this one's easily done in my head. I can easily do this one in my head. 9 times this 45 is going to be 9 times 5. The square root of 9 is 3. Square root of 5. And then I get 27 times the square root of 5. So something like that, that's easily done in my head. But look at number 12. 3 times the square root of 578. This one's going to take me a minute if I try to do this using that old method of taking 578 and starting to divide by perfect squares. So I'm going to use the y equal method on this one. So y equal 578 divided by x squared. Go to your table, second graph. I think I already see the answer. But I'm looking in the y column again for where it changes over from 1 point something to 0 point something. So that means my answer is the first whole number I come to in the y column, which is a 2. 17 on the outside, 2 left over. 17 on the outside, 2 left over. And don't forget there's a 3 out there. And 3 times 17 is 51, square root of 2. And there's your answer for number 12. So I've shown you both methods on how to simplify a radical where you do it by hand. But honestly, if you do it by hand and it's a large number, you're probably going to grab a calculator anyway. So there are your notes on Simplifying Radicals Review, Chapter 4, Lesson 1.